A particle moving with uniform acceleration has a velocity of 6 meter per second at a distance 5 meter from the initial position. After moving another 7 meter, the velocity becomes 8 meter per second. The initial velocity of the body is. So first let us visualize the equation. So let us say the body starts from position A, it moves till position C, and an intermediate position is B. According to the question, at a distance 5 meter, so if AB is 5 meters, then the velocity at B is equal to 6 meter per second. So I can say that VB is 6 meter per second. Later, after moving another 5 meter, which means this much distance, BC is 7 meters. After moving another 7 meters, the velocity becomes 8 meter per second. So VC is 8 meter per second. Now, for the motion along AB, we can write the equation as V square is equal to U square plus 2AS. Now what will be the final velocity? The final velocity will be VB. So VB square is equal to initial velocity. Now initial velocity here is not 0 because the body is never set to be at rest, which means it possesses some amount of initial velocity. Let us call that velocity as U or UA, or maybe just U. So it's U square plus 2 times A times S. How much is S? S is 5 meter. So what do we get the first equation as? We get the first equation as, how much is VB square? VB is given as 6 meter per second square. So that becomes 36 is equal to U square plus 2 times 5 is 10. So we get 10A. Now for the second portion of the motion, which is for the motion along BC. For the motion along BC, we can again write the same equation, which is V square is equal to U square plus 2AS. Now, what is V here? V is velocity at C. So this becomes VC square is equal to U square. U square here would vary. Why? Because here the velocity, the body is moving from B to C, in which case U would be VB. So we can replace U with VB square plus 2 into A into, how much would be S? S would be the distance between B and C, which is 7 meters. Now, so this will give us the equation VC square, which is 64 is equal to VB square, which is 36 plus 2 into 7 is 14, 14A. So 64 minus 36 is equal to 14A. We know that 64 minus 36 is 28. So 28 is equal to 14A, in which case A is equal to 2 meter per second square. Now, if A is equal to 2 meter per second square, we can use this information over here, with this equation. What do we get out of it? So we get 36 is equal to U square plus 10 into A is 2. So we get 36 is equal to U square plus 20, which means U square is equal to 36 minus 20 is 16. So U is 4 meter per second. Well, ideally the question coming to mind shouldn't we be using plus or minus 4 meter per second? Yes. you should be using u is equal to plus or minus 4 meter per second. But what happens here is, since the motion is along the positive x-axis, the velocity here has not changed. It has not mentioned that the body is turning its position at any point, which means the velocity vector will also have the same direction, and therefore we can take positive 4 meter per second to be the correct answer. In which case the correct option would be option B, that is 4 meter per second.